Welcome to my presentation. My name is Julius Dada. Today's presentation will be on latitudes and longitudes. I will apply trigonometric ratios, arc length, and alternate angles when you have parallel lines. Welcome. We'll use a right angle triangle to get the trigonometric ratios, where we have a triangle ACB and angle theta. We have a hypotenuse, we have the opposite side, and we have the adjacent side. To get the cosine of an angle, we say cosine of theta, our angle theta here, is equals to the adjacent side, that is AB, all over the hypotenuse, which is our AC. The sine of theta will be equals to the opposite side, which is BC, all over the hypotenuse, which is our AC. Tan theta is equals to BC all over AB, where BC is the opposite side of the angle theta and AB is the adjacent side of the angle theta. The arc length AB is equals to theta all over 360 times 2 pi r times 2 pi we use theta all over 360 because the arc subtends an angle of theta at the center of the circle, and therefore we need just a fraction of the circle. When you have two parallel lines, AB and CD, when you draw a transverse EF connecting the two lines, the angle theta is always equal to this other angle theta. We call them alternate angles. The diagram we have here is a diagram of the Earth, which is nearly spherical. You can see that it is almost a sphere. In this diagram, we have the North Pole and the South Pole. That line joining the North Pole and the South Pole is called the polar axis. We call it the polar axis. Latitudes and longitudes, they are imaginary lines drawn on the Earth's surface. They help us locate a position on the Earth's surface. The latitudes are drawn horizontally and perpendicular to the North Pole, South Pole, which is the polar axis. What we are calling the small circle here, this one is a latitude that is drawn horizontally and it is perpendicular to the polar axis at this point where you have the center of the small circle. The equator is the greatest latitude. It is referred to as a great circle because the radius of the equator is the same as the radius of the Earth. From the center of the Earth to the plane, from the center of the Earth to point Q will have the radius of the equator plane, which is equal to the radius of the Earth. Longitudes are drawn from north to south pole, and they are referred to as great circles because they have the radius equal to the radius of the Earth. All the other latitudes are parallel to the equator and they are small in size, and their radius is denoted by small letter r. They are all parallel to the equator, and we refer to them as latitudes north of the equator or latitudes south of the equator. For the longitudes, we have a meridian that we call the Greenwich meridian that passes through London. We use it as a standard from which all the other longitudes are either east or west of the Greenwich meridian. Just like they use the equator as a standard so that we have all the latitudes are north or south of the equator. Now for the longitudes, we have they are either east or west of the Greenwich meridian, and it is given its degrees as 0 degree. It's given as 0 degrees. The same case with the equator, it is also given as 0 degrees. The longitude that passes through point P is theta degrees east of the Greenwich meridian. The maximum possible angle of longitude is 180 degrees east or 180 degrees west. Now we are turning on to latitudes. If the Earth is cut by planes perpendicular to the polar axis, the circles formed on its surface are called lines of latitude. The circles formed on its plane are called lines of latitude. And we have the greatest line of latitude, which is the equator, which is given 0 degrees. All the other latitudes are either north or south of the equator. The equator divides the Earth into 2 equal parts. All the other latitudes are small circles. They give us a small circle, but the equator is a great circle because the radius of the equator is the same as the radius of the Earth. All the small circles are parallel to the equator. The latitudes are measured in degrees north or south of the equator. We are now finding the relationship between the radius of a small circle, small letter r, and the radius of a great circle, whose radius is capital R. Note that every small circle is parallel to a great circle. And therefore, line BA is parallel to line OK. And it follows that now the alternate angles, our transverse is AO. And therefore, angle theta is equal to this other angle theta because they are alternate angles. When you go to the lower latitude, we'll have our DC parallel to OK. And therefore, with our transverse OC, we'll have that angle alpha is equals to this other angle alpha. With our right angle triangle, BAO, which is right angled at B, we can get the cos theta as the adjacent, which is R, all over the hypotenuse, which is our capital R. From there now, we can multiply by R on both sides. To get rid of the denominator, we multiply by R such that we'll have R cos theta is equal to the small r. And that's our relationship. From here, we can see that the radius of a small circle is always equal to the radius of a great circle, that is the radius of the equator, multiplied by the cosine theta, where theta is the latitude, either north or south of the equator. For the latitude that is at C, we'll have cosine of alpha is equals to the radius of that small circle over the radius of the great circle, multiplying by r on both sides. We'll have that r cos alpha is equals to the small r, which is the radius of the small circle. It follows that when you have the radius of the great circle, you can get the radius of the small circle by multiplying the radius of the great circle by the cosine of the latitude. We can say therefore that the radius of a circle of latitude theta degrees north or south of the equator is given by r cos theta, where r is the radius of the earth and theta is the latitude. The next thing to note is that the position of a point on the earth's surface is given by its latitude and longitude, given by ordered pair, latitude, longitude, in that order. We always give the ordered pair, starting with the latitude, then longitude. Note, the latitude of a place is measured in degrees north or south of the equator. The next thing to note is that there is only one such place on the Earth's surface, and the maximum angle of latitude is 90 degrees north or 90 degrees south of the equator. It is either 90 degrees to the North Pole or 90 degrees to the South Pole. So the maximum angle is 90 degrees. Now we move on to calculation of the distance on the surface of the Earth in kilometers and in nautical miles. We'll start with the distance along a great circle. To find the distance between 2 points on the same great circle, we find the angle separating the 2 points at the center of the Earth, then apply the formula for finding the arc length between the 2 points in kilometers and in nautical miles. In kilometers, the arc length is given by theta all over 360 times 2 pi r, where theta is the angle separating the 2 points and r is the radius of the Earth. We usually take the pi as given and the radius of the Earth as given. The nautical mile is defined as the length of an arc of a great circle which subtends an angle of 1 minute at the center of the Earth. Taking r as 6370 and pi as 22/7, 1 minute is equals to 1/60 of a degree. 1/60 of a degree. Therefore, the arc length PQ will be given by 1 over 60 of a minute multiplied by 2 pi r all over 360. All this is equals to 1 nautical mile. So 1 nautical mile will be equals to 1 all over 60 times 2 times 22 over 7 times 6370 times 1 all over 360. This one will give us 1.85 kilometers. Therefore, the arc length PQ is equals to 1.85 kilometers. 1 nautical mile subtend an angle of 1 over 60 degrees. Therefore, 60 nautical miles will subtend an angle of 1 degree. It follows that 2 pi r times 1 degree all over 360 is equal to 60 nautical miles. A nautical mile is the standard international unit measuring distances traveled by ships and aeroplanes. In nautical miles, if the angle is not 1 degree and the angle is theta, we get the distance in nautical miles as 60 times theta nautical miles. An example here, a plane flew due south from a point A, which is 60 degrees north, 45 degrees east, to a point B. The distance covered by the airplane was 8,000 kilometers. The question is, determine the position of B. For the solution, we need a rough sketch of the globe to guide us to get where the points B and A are. We have the equator, which is 0 degrees. We have point A, which is 60 degrees north of the equator, and it is on the longitude 45 degrees east. So this is our point A. If flew to point B, the plane flew due south. So point B must be south of A. We are given the distance AB, which is our arc length, as 8,000. Therefore, what we need to look is for the angle between the point A, the angle between point A and B that is subtended by the arc length AB. We call that angle theta. Therefore, the distance arc length arc B should be equal to 2 pi r all over 360 times angle theta. It is along a great circle. Because it is due south, it is along a great circle. Therefore, the radius of that great circle is equal to the radius of the earth. We are asked to take pi as 22 over 7 and the radius of the earth as 6370. We are given the distance, we are given the arc length AB as 8,000. So 8,000 is equal to 2. We are multiplied by 22 over 7 times our radius, which is 6370, times our theta. All these we are dividing by 360. Working out, we get that 8,000 is equals to 111.2 times theta. Therefore, our theta is equals to 8,000 divided by 111.2. Theta is equals to 71.94 degrees. We note that angle 71.94 degrees is far below the equator. And up from 60 to the equator, we have 60 degrees. So we need to subtract 60 degrees from 71, so that we have 71.94 minus 60, we get 11.94. 11.94 degrees is the degree that is below the equator. And therefore, position of B will be 11.94 degrees south, 45 degrees east.